Welcome to Creata classes. In this lecture, we will cover medians in a right angle triangle. As a special case, we will study the medians in a right angle triangle. This is a special type of case. We know what is a right angle triangle. Right angle triangle is a triangle with one angle as 90 degree. This is a right angle triangle. Here this angle is a 90 degree angle. And we also know the side opposite to 90 degree angle is known as hypotenuse for this triangle. Here this side is the hypotenuse. And the remaining two sides are known as legs of the triangle. This is a small introduction to the right angle triangle. In this lecture, we will cover the medians with respect to this right angle triangle. As a special case, let's proceed to the first property. The first property is that in a right angle triangle, median to hypotenuse is equal to the half of the hypotenuse. Here, this property is talking about the median which is connecting with the hypotenuse. Here, this is a hypotenuse, so this is the median that we are talking about. Median is a line segment which joins the vertex with the midpoint of the opposite side. Here, D is the midpoint of the hypotenuse AC. As per this property, this median will be equal to half of the hypotenuse. Here, D is the midpoint, so AD will be equal to DC. AD and DC will be the half of the hypotenuse. So as per this property, AD and DC will be equal to BD. Means AD is equal to DC is equal to BD. Note that this property is only and only for right angle triangle. Do not get confused with any other triangle. Only if the triangle is a right angle triangle, then the half of the hypotenuse will be equal to the median which is connected with the hypotenuse. Let's prove this property. We have a triangle ABC with D as the midpoint of AC. So AD will be equal to DC. Here AD is the median which is connecting the vertex B with the hypotenuse midpoint D. Let's have the point E as the midpoint of BC. Here E is the midpoint. Here we have taken E is the midpoint, means BE will be equal to EC. Let's join DE. We have got a line segment DE. If we observe the triangle ABC and the line segment DE, are you able to correlate this figure with the midpoint theorem? D and E are the midpoint of AC and BC respectively. So as per the midpoint theorem, if a line segment which is joining the midpoint of two sides of the triangle, then that line segment will be parallel to the third side. So as per the midpoint theorem, DE will be parallel to AB. Why? Because D and E are the midpoint and DE is connecting the midpoint of the two sides of the triangle, that is AC and BC. So DE will be parallel to AB. Moving further, if AB and DE both are parallel to each other, and we know angle ABC is 90 degree angle. ABC is a right angle triangle. So angle ABC and angle DEC will be equal to each other. Why? Because they are corresponding angle. AB is parallel to DC and we can assume BC as a transversal. The corresponding angles in case of transversal and the parallel lines are equal. So we got angle DEC also as equal to 90 degree. And BC is a straight line. So by linear pair axiom, we can say this complete angle will be equal to 180 degree. So angle DEB will also be equal to 90 degree. Okay, both of this angle will be equal to 90 degree. BC is a straight line. So 90 plus 90 will be equal to 180 degree. Got it? Further, if we take the triangle DEC and triangle DEB, are you able to observe both of these triangles are congruent triangle? How? Let's see. DE is equal to DE, that is the common side. BE is equal to CE. Okay, E is the midpoint of BC. So both of these line segments will be equal to each other. Further, just now we have proved angle DEB is equal to angle DEC. Okay, both of these angles are 90 degree. So by SAS rule, we can say both of these triangles are congruent to each other. And by CPCT, that is the corresponding part of congruent triangles, we can say the corresponding sides are equal. That is BD will be equal to CD. both of the sides of triangle will be equal to each other, and that is the proof of our property. That is BD, that is the median connecting with the hypotenuse, is equal to half of the hypotenuse, and DC is the half of the hypotenuse. So we got AD is equal to BD is equal to DC. Okay, we have done a property. Based on this property, we will have a small observation. We have just got that length of these three line segments are equal. Can we say point A, B and C are equidistant from point D? Okay, we can say so, as AD, BD and CD are equal to each other. Are you able to correlate this with the fundamentals of circles? In circles, we have seen that all the points on circumference or boundary of the circle are at same distance from the center of the circle. And this distance is known as radius of the circle. So as point A, B and C are equidistant from point D, so can we say D as a center and AD, BD and CD as radius of the circle? Let's denote these three line segments as R. So with D as a center, can we draw a circle with radius as R? We got a circle touching the three vertex of the triangle ABC. The median BD or half of the hypotenuse is the radius of this circle. This circle is touching the three vertex. So this circle is a circumcircle that we will cover separately in a separate lecture. Got the point? In case of a right angle triangle, medians joining the hypotenuse act like a radius of the circle with center as the midpoint of the hypotenuse. And this circle is the circumcircle, that is, it will touch all the three vertex of the triangle. Got the fundamental? Let's take a small question. Refer the figure. In the given triangle PQR, find the length of median QO. Let's refer the figure. QO is given as median for this triangle and PQR is given as a right angle triangle at point Q. QO is the median, so can we say O is the midpoint? Medians join the vertex with the midpoint of the opposite side. So QO is a median and O is the midpoint of PR, that is the hypotenuse. And just now we have seen that the median joining with the hypotenuse is equal to half of the hypotenuse. So can we say QO is equal to half of PR? So finding the value of QO, we have to find the value of PR. For that, let's check the triangle PQR. The legs of the triangle are given as 3 and 5. Let's apply the Pythagoras theorem. We got 3 square plus 4 square is equal to PR square. On solving, we got PR as equal to 5 unit. We got PR as 5. And in the question, we have to find the value of QO, that is length of the median. So we got QO is equal to half of PR, that is half of 5 units. That is 2.5 unit. Okay, that is the answer of the question. Okay, very simple. Just a small question to show the implementation of the fundamental that we have just studied. Let's move further to the next property of the median in a right angle triangle. Let's see. Now we will see a small relation of medians in a right angle triangle. This relation that we are just going to study are generally covered in several competitive exams. So this small relation is important. Let's see what is the relation. Let's take a right angle triangle ABC. Angle B is 90-degree angle. Let's take the median as CN and AM. N and M are the midpoint of AB and BC. Let's assume AN and BN as Y. Both of these line segments will be equal to each other as N is the midpoint. Similarly, let's assume BM and MC as X. Both of these will be equal to each other. Further, are you able to observe triangle ABM and triangle NBC? These two triangles are also a right angle triangle. Let's take these two triangles out of the figure. If we apply the Pythagoras in both of these triangles, we got, for the first triangle, that is triangle ABM, we got x square plus 2y square is equal to AM square. Here AB will be y plus y, that is 2y. Similarly, for the triangle NBC, we got 2x square plus y square is equal to CN square. Here BC will be x plus x, that is 2x. Let's add both these equations. We got 5 times x square plus y square is equal to AM square plus CN square. can we replace x square plus y square with nm square? How? Let's see. If we take the triangle NBM, this small triangle, and apply the Pythagoras, we got nm square is equal to x square plus y square. So we can replace x square plus y square with nm square. So we got our relation as 5nm square is equal to am square plus cn square. Further, if we observe the triangle ABC and the line segment NM, here N and M are the midpoint of the side AB and BC respectively. Are you able to compare this with our midpoint theorem? N and M are the midpoint, and as per the midpoint theorem, the line segment joining the midpoint of two sides of the triangle is parallel to the third side and is also equal to half of the third side. So we can say NM and AC are parallel to each other, and also NM is half of AC. So can we replace NM with AC by 2? Let's do so. We got 5 times AC by 2 whole square is equal to AM square plus CN square. On solving, we got 5 by 4 AC square is equal to AM square plus CN square. This is the relation. Here AM and NC are the medians for this triangle and AC is the hypotenuse for this triangle. As per this relation, 5 by 4 times AC, that is hypotenuse square, is equal to sum of square of the two medians. This is one of the important relation that is generally asked in the competitive exams. So we have covered this relation. Okay, we have done the two properties of medians with respect to a right angle triangle. The first one we have done, that is, in a right angle triangle, median to hypotenuse is equal to half the hypotenuse. And secondly, we have done this relation, that is AM square plus CN square is equal to 5 by 4 AC square. These two properties or these relations are only and only applicable for a right angle triangle. This is very important. Sometimes a student get confused and apply this relation in some other type of triangles also. So note it down. So that's it for this lecture. Thank you very much for being with Creata classes.